All right, so our first strategy for math is going to be plugging in. Now this whole unit, I just want to make sure you're aware of, all I'm doing is I'm teaching you strategies that are in addition to the actual mathematical way of solving questions. So all the problems we're going to be doing here have mathematical, whether it be algebraic or whatever methods to actually solve the problem. I kind of like to think of this as just a backup plan. If you get stuck, well, what are you going to do? You can give up, you can randomly guess, or you can apply a strategy. And there are times too where the strategy is faster than the algebra that you would normally require to solve the problem. So again, it's just really up to you, and it's just more about just giving you multiple tools to be able to solve problems. So that's why I like to start with the strategies, because maybe you're stuck later on in an algebra lesson or the arithmetic unit, and you can apply the strategy and get to the answer that way. So part of the setup here is to solve these three examples that are on the screen. So what you should do is try to do them real quick. You pause the video and then come back and see how you did. So here we go with the first one. Suppose you're at a hardware store, you buy 6 bolts for 5 cents each. So those 6 bolts for 5 cents each is going to cost you, in this case, 30 cents. You give the clerk $1, how much change you receive. So you pay $1 for 30 cents, you're going to get 70 cents back. So you should have had 70 cents for the first example. The second one says, suppose you buy 12 bolts for 15 cents a piece. So we're going to multiply those out, and we're going to get $1.80. So when you get $1.80, you give the clerk $2. How much change do you get back? Well, you're going to get 20 cents back. Now, overall, I would say these problems should be what I would call an easy level difficulty math question. And then what they're doing is they're taking this easy question and they're making it super hard. They're doing it by adding variables to the problem. So you're going to buy P bolts instead of 12 bolts or 6 bolts for C cents each, and you give the clerk D dollars. Now what's your change? You need to write an expression to represent the change. A lot of people are going to write this, D minus PC. I'm thinking, okay, take the amount that I paid, subtract the, or take the amount of money that I gave the clerk, and subtract that from how much the items are, and they'll give me my change. And that's almost correct, and that would probably be an answer choice on the test. But what you have to do is you have to convert the dollars to cents. So you have to multiply the dollars by 100 to do that conversion. So this should be your answer. And this problem is usually considered hard. I get most people on this one. And again, notice it's the same question as these, but it's just a harder version. So what you're able to do then is, if you use this method called plugging in, you can actually solve one of these easy problems. Now most people would probably prefer to do this first easy one as opposed to the second one, and that's the beauty of it, is you can pick whatever numbers you want. So make it as easy as hard as you prefer. I would assume you want to make it easy, but that's really what plugging in is used for. It's making hard problems easy by getting rid of some of the algebra. So in order to plug in, we have to know when. So these are the times when we want to do that. So first off, if you see variables in the answer choices, that's a good time to plug in. Like we see in number 2, you see some variables in the answer choices. That usually means you can plug in for y. Number 2, if the question asks you to find a fraction or percent, like you see on number 1, it's asking you to find a fraction. All the answers are fractions. And then down here, they're asking for fractions. Then you can plug in on those. Or if it's asking for percentages, notice number 4 is asking for percentages. Those are times that you're going to be able to plug in. Now, if you're doing a percentage plug-in, let's try to make sure we pick 10 or 100, because taking percentages is easy when you're using those numbers. Like 20% of 100 is 20. 20% of 10 is 2. 20% of 7 is not so easy. So again, you want to make the problem as easy as you can, so try to pick 10 or 100. And there are certain times you see could or must. These usually show up in the Roman numeral questions. If you're plugging in on those, you may have to plug in more than once. So just pay attention if you see those words. So that'll be a clue that, hey, you can plug in, and you just be aware you may have to plug in more than once. And try to avoid certain types of numbers, 0 or 1. Never really pick 0 unless they tell you specifically that you can pick it. Like on grid-ins, sometimes they'll tell you. You can be like an integer. Well, an integer can be 0. I guess you can plug in there, but that's pretty rare when you ever see something like that, because usually you can't plug in on grid-ins It's rare, it doesn't mean you can't. So that's usually, I would just say don't pick 0. If you pick 1, I mean, try to avoid picking it if you can pick something else that's better. Otherwise, just make sure you're checking your answers and make sure that that number doesn't repeat, because when you multiply a number by 1, it doesn't change. You divide a number by 1, it doesn't change. So you have a high probability of getting multiple right answers because your numbers aren't changing. So just be aware of that if you're picking those numbers. So at this point, we're going to go ahead and try some of these examples so you can see how it works. All right, so for example 1, what we have here is we say x over y. This is what they're giving us. So x over y is equal to 6. And then they say, what is the value of 12y over 7x? So we're looking for this. Okay. So in this case, if you're going to plug in, what you first want to recognize is all your answer choices are written as fractions. So this is going to be one of those fractional plugins if you're going this route. So what that means is when you plug in for your variables, we want to make sure that, first off, the fraction just means that we can plug in. And then what we're going to do is pick some numbers so that x over y is equal to 6. Now, generally, in the rules that I give you, as I say, try to avoid picking numbers like 1 or 0. What I'm going to say, if you do pick 1, just make sure you're checking all your answers. But overall, on fractional plugins, it's usually not an issue. So you'll see me pick 1 here. Again, normally if I do that, especially if I have a bunch of expressions as my answer choices, I'm going to just make sure I double check and make sure I don't have repeats. But in this case, you'll see it's not going to be much of an issue. So I'm just going to go ahead. I'm going to say let's call x 6 and let's call y 1. Because if you go 6 divided by 1, you get 6. So now that I have those numbers, let's figure out what 12y over 7x equals. So 12 times y, that's going to be 12 times 1 over 7 times 6. So I plugged in 1 for y, because that's what I had for y, and x I called 6. And here you can, before you multiply, it's a little bit quicker if you just see, hey, these cancel. That gives me 2, so you end up with 2 sevenths. So all you need to do now is look at your answer choices, and answer choice B is going to be 2 sevenths, so that's going to be your answer for number 1. And that's plugging in with fractions. The next one we have is going to be number 2, and this one, what I like to think of plugging in is it's like a backup plan. Like if you're working on if you're like a mechanic or a construction worker, and you know how to use your tools, but maybe you get into a situation you can't get to work, you can pull out your duct tape. Well, this is our theoretical duct tape for math problems. So I'm going to solve number 2. I'm going to solve it by plugging in. But then you'll also notice it's kind of a guess and check type method here. And I'll show you actually how to solve it when I'm done. But that's really where plugging in is going to be really helpful, is when you don't know the actual mathematical way to solving something, so you plug in instead. So here, this is a percentage plugin because they're talking about percentages. You also see in your answer choices you have a bunch of variables. So you have those 2 clues that kind of tell you, hey, this is a plug-in question. So we have this sale. Jason bought a pair of shoes at 25% off the store's price. The amount he paid was y dollars. So we know we're starting here with y dollars, and we want to plug in a number for y because that's the variable in our answer choices. So I kind of know that's going to happen. Now, if it's a percentage plugin like this one is, I'm going to say 100, which in this case represents $100. Now, I don't know what y represents overall, but I know it's probably going to be a cost. So the amount he paid was y dollars. So that's what he ended up paying when he went to the register, which included a 6% sales tax. So what is the original price of the shoes? So we paid this much. What we know from here is that this price that we paid, if I want to get the original price, I have to go up 25%. So that means we're going to be somewhere around, because what I'm not including, and that goes in here, is the 6% tax that we're paying. And this is where I'd say most people get confused. So I'm just going to kind of pretend it's not there, but no, it is. So I know approximately my original price is somewhere around $125, somewhere around there. So what you would then do is look for an answer that gives you something close to $125. So when you start plugging these into your answer choices, you just kind of start checking and which ones get you close and which ones don't. Now, if you plug in A, 0.25 times 100, it's really nice when you plug in 100 because you're going to get, 0.25 times 100 is 25. So you know it's not going to be A. Next up, you have B, which is 0.69 times 100, so that's 69. That's not going to work. C, you plug that in, and again, that's going to give you, and I don't have the calculator to do it here, but it's going to give you a number that's way off from 125. And you just check all these numbers, you plug them in. D, when you go y divided by 0.75 times 1.06, again, you're going to get about 126 or something like that. You're going to get something close to 125. It's not exact, but it's the closest one, and you'd be pretty confident in picking that answer, even if you had no clue what to do with that 6% sales tax. But, you know, there's a way to solve this, so I do want to talk about that actual method. So the actual way of solving this would work this way. And this is actually going to show up in an arithmetic lesson, but that's the plugging in method, and you would have gotten the answer with that method. Now here what we would do is say the original price, I'll call that original price theta. It's a Greek letter, but it looks like an O. So what you're doing to get to your get to the register when you're paying, so you're going to take this original price and you're going to take off 25%. To take off 25%, you multiply by 0.75. Because if you take off 25%, you're left with 75%. So this is going to be in our arithmetic lesson on percentages, and also we'll do a little bit of this in this unit as well with converting equations. But we're taking 75% of the price, and then we're going to add 6% of the sales tax onto it. So we're going up 6%. So when you go up a percentage, you add that number to 1, whereas this one I subtracted the percentage from 1. This is 1 minus 0.25. This will be 1 plus 0.06, which is 1.06. So when you go to the register, you're going to take the original price, take off 25%, add sales tax. That gives you y. So you'll notice y ends up equaling this if you divide both sides by these values. I'm not going to write them all out again, but you end up with y equals, as you do it over here as well, you'd have, or in this case, sorry, they wanted the original price, so we're looking for theta. So theta equals y over the 0.75 and then the 1.06. And that's what our answer ended up being anyway, so that's where D comes into play. So that's going to be number 2. This is plugging in, that's solving algebraically. Again, if you see that and understand that rule, we'll go over that rule, just like we do anything else. That's also great, but you have that backup plan to help you out also. So moving on, we're going to go to number 3. They give you an equation. Now, this one is hopefully an equation you already know, but at the same time, if you don't already know it, they're going to explain it to you anyway. But usually on the SAT, they like to give you equations you've never seen before, so get used to them trying to explain what everything represents. But we have this volume formula, so volume equals pi r squared h. It's the volume of a cylinder. And we have 2 cylinders here. They say a right circular cylinder is equal to radius r squared times the height h and pi, and they're just describing the equation. We should hopefully already know the volume formula for a cylinder and r and h. So with all other components remaining the same, if a person finds that the radius of cylinder A is 5 times greater than the radius of cylinder B. So they're talking about 2 cylinders. Usually when they do that, I like to set up A and B. I'm going to kind of write down the information separately in its own column. And they're telling me right off the bat, the radius of cylinder A is 5 times that of B. So we have the 2 radii, and this is where the plugging in comes in, because I don't know what the radius is, but I know the relationship. Now, the key on this, look at the answer choices. They're all fractions. They're asking for fractions, which tells me I can plug in. It's okay. So here I go. I know that A is 5 times greater than B, so I'm going to call the radius 5 and 1. That's 5 times greater. Now, after they say that, literally the next statement is, then the volume of B is what fraction of the volume of A. And you may be looking like, well, what about the height? They haven't given me the height yet. Let's jump back to earlier in the question where they said all other components remaining the same. So they're telling you that the other components don't change. Well, the other component is h. That's the only other thing, because pi is a constant. So call this whatever you want. It doesn't matter. So I'll call it 2. Sounds good to me. So what I'm going to now do is I'm going to find the 2 volumes. So the first volume is going to be V equals pi times r squared, so 25, times h, which is 2. This volume is pi times r squared, which is 1, times 2. So these are my two volumes. I end up with 50 pi, and I end up with 2 pi. Now what they want me to do is divide. We want to know which one to divide on top and bottom. So the volume, the volume of cylinder B is what fraction of the volume of cylinder A. So we're going B divided by A. So I'm going to come up here. I'm going to go B divided by A. The pi's cancel. 2 over 50 is 1 over 25. And then 1 over 25 is answer choice B. So that's going to be your answer for number 3. And then lastly, number 4 says we have a rectangle to be altered by increasing its length by 20%, decreasing the width by 30%. Now notice the answer choices are all percentages. The question's all percentages. This is a percentage plug-in. So when they describe the rectangle, here's a cool little trick. A rectangle, a really good rectangle to use in this case, is something called a square. Maybe you've heard of it. You know, a square is a rectangle. It has 4 right angles and opposite sides are congruent. That's what a rectangle is. So I am drawing a square. Now we want to make sure we pick good numbers here. When we have percentage plugins, I tell you there's 2 sets of numbers you want to use, 10 or 100. So I'm going to call these sides 10, which would make the area 100. I get both numbers, which is great because we're kind of changing both. So I'm going to alter the length and the width of this thing. So I'm going to make a new rectangle. This will probably actually be a rectangle. And I'm going to increase the length by 20%. So I'm taking this 10, I'm going up by 20%. Because I'm using 10, hopefully it's easy to tell that 20% of 10 is 2. So I'm going from 10, I'm adding 2, so I'm going to get 12. And then I'm decreasing the width by 30%. So I'm taking away 3. So I'm going from 10, take away 3, you end up with 7. So our area is now going to be 12 times 7, which is going to be 84. So this is what we're really looking at, is these two numbers right here. We went from 100 to 84. So we went down, it looks like 16%. So we literally went down 16, but we don't have to convert that to percentages because it's out of 100. So we literally just put a percentage next to it. And down 16% is going to be answer choice A. And that is plugging in.